Hi, hello, welcome to part 5 of the chapter 6 lecture. In this part, we are going to talk about resonance structures, and we are lightly going to introduce ourselves with the resonance structures. I'm not going to expect you to do a lot of things with it. And again, I'm just going to introduce you the resonance structure. Where resonance structure is really popular is in organic chemistry. And in organic chemistry, if you have to take it, you will be extensively required to practice resonance structures there. So what are we doing here is, what we did in the previous section of this chapter is we learned about formal charges. If you remember, we worked on ozone structure. We said that one ozone let me write those charges to bring you the memory. We said that this oxygen has zero charge, and this oxygen has plus charge, and this oxygen has -1 charge. That is how they have the overall neutral charge. But who decides which oxygen is going to have the -1 charge and which oxygen is going to have zero charge? It's not something easy to decide, right? So that is where, and also when you try to chemically identify, it is identified that literally you cannot pinpoint which oxygen is holding negative charge, which oxygen is holding the zero charge. So we come up with the explanation of resonance structures that resonance structure is the one that delocalizes the electrons. Resonance structures differ only in the positions of their electrons. What it means is this structure is exactly same as this structure. They both are ozones, and they both contain 3 oxygens, and they both are neutral. It is not a different molecule. But only difference is the position of the electrons changes as the negative charge shifted from right side to the plus side. Sorry, the middle one is not. This one, 0. You see, the 0 formal charge on far left oxygen shifted to far right oxygen. It is because the number of electrons shifted. How it is possible is a resonance structure moves the electrons from one side of the molecule to another side of the molecule, and it has a fixed rule of moving these electrons. It only moves to a maximum of 3 positions. Let's say you have electrons here. I'm going to label it as 1, this one has 2, this one has 3. Let's see if there's right way to go. Okay. If I do that. So this is how I move the electrons. I convert this lone pair to a double bond. And when you try to make a double bond, central oxygen has more than 8. So it immediately kicks out one of the double bond converted into lone pair. So that double bond converted into lone pair like that. And lone pair here converted into a single bond. That is how charges shifted. Resonance shifts the electrons between 1 to 3 positions. From 1, it shifted to 3. So a resonance structure is, just for the definition, a resonance structure is one of 2 or more Lewis structures, a single molecule that cannot be represented accurately by one Lewis structure. Something like this you cannot accurately represent because you cannot identify which atom is which. Any one of the outside oxygens can hold a -1 charge or 0 charge at any given moment of time, and we don't know which one of these oxygens is holding -1 charge or 0 charge, because when you try to chemically identify, they happen to have a hard time in doing that. That's why we come up this explanation of there is no negative charge in one of these oxygens. They were just shifting electrons all this time. Okay. So that's why, yeah, it sounds complicated, right? That's why I said I'm not going to expect much in return from you. I'm just introducing this, and we just move on. I'm not going to stress you a lot on you mastering this topic. This is not needed at this stage. I'm just going to show different Lewis structures and move on. Carbonate ion is one of the example where you can write Lewis structures. Carbonate ion formula is CO3 to minus. So when you draw Lewis structure for it, this is how it will look like. There are 3 oxygens, and this one has a -1 charge. This one also has -1 charge. This one has 0 charge. Whereas by second structure, when you draw Lewis structures, how do you do that? You move the lone pair here to this, and this double bond becomes a lone pair. So it becomes a lone pair like this. Excuse me. So you have a lone pair like this and a double bond. So now this one has a, instead of 0, -1 charge, -1 charge, 0, +1 charge. Now you can make another new resonance structure by converting this lone pair to making a 3 lone pairs again. So that lone pair become double bond, and you made a new lone pair. So this one is neutral now, and this one is -1 charge, and this one is -1 charge. Here it should be -1 charge. Got it. So that's how resonance structures work. Right? Resonance structures, think of them as a delocalization of electrons. And book doesn't directly discuss it. Is what it means is, non-metals have a hard time holding charges on them because they were not metals or ions. So to minimize the burden of holding this additional charge, be it a positive or negative, they just share it with another atoms. They delocalize the electrons. That's what resonance structure is. If at all possible, between 1 to 3 distance of atoms, they just share the electrons between them. And benzene is another great structure that we use to explain the delocalization of electrons. I don't want to get into the details of it and make you guys crazy about it. Okay, let's move on. You don't really need to know that. I'll work on simple examples at this stage. You don't know what is that skeleton structure is yet. You will have difficult time in understanding what are those structures. That's why I'm just skipping this. Not needed. If at all you have to take organic chemistry, you will know everything about the structure at the time. All right, let's work on just this problem and call it a topic for this resonance topic. So the question is saying that, the natural gases or the coal, well, especially coal, we scared about it, and we don't, it's not really great for environment for multiple reasons. The one is that it could produce carbon dioxide, and the another less known fact is that it can also produce toxic chemical SO2, where it would become much more toxic because when SO2 oxidizes, it oxidizes into SO3, and when it combines with the rain, it releases sulfuric acid. It all makes huge toxic acidic water acid rain, which is not great. That's why we should avoid first a few minutes of rain exposure if at all it is raining, especially in a polluted area. So coming back to this, the question is asking us to draw the Lewis structure of SO3 and show multiple resonance structures. So at this stage, you should be confident about drawing Lewis structures. Sulfur should be a central atom. Oxygen should be connected to the central sulfur atom. So it should look like this. Here you have formal charge of 0, formal charge of -1, formal charge of -1 as well. And if you count formal charge on sulfur, it should be +2. That's how SO3 is neutral. That's +2 and -1, -1. And if you try to draw Lewis structures just like carbonate ion, I'm going to erase all the ink and show you my technique of drawing Lewis structures. You should follow 1, 2, 3 method, keeping double bond in 2 and 3. You convert a lone pair to this, you kick the lone pair back. That's how you would write Lewis structures like this. From this to this, you got this Lewis structure, and from this to this, you got this Lewis structure. That's how you write the Lewis structures. Okay, that's all about resonance structures. Again, as I said, You just need to know that, when you try a loose structure with a fixed forward charge, it's not going to stay there all the time. If at all, it has exposure to this kind of framework. This is where resonance happens in shortcut. When you have 3 atoms, 1, 2, 3 distance, with a double bond between 2 and 3, and with a lone pair at 1, you will have a resonance structure. For now, you just need to know that. Okay, that's all you need to know. You can write a resonance structure by sending electrons to make a double bond and converting this one to a lone pair again. Those are resonance structures. What it's saying is electrons don't just stay at one place just because you put them in a loose structure. They delocalize if at all there is a neighboring double bond that is present. Okay, that's all for this topic. I'll see you in last part of next section.